afternoon, everyone, and welcome to the last session, to the afternoon session. I hope you enjoyed the lunch and had the chance to connect with other participants. The last session, we will talk about new technologies, new solutions for decarbonizing the industry. The first part of the session, we will have two interesting talks based on new technologies on hydrogen technology, okay? And later on, we will have a roundtable discussion focused on the innovative technologies for decarbonizing the industry. Okay, just I will remind again to the audience that is online. Fatwa, we know that you are there. We miss you here in the consortium, so hello. And okay, so the people that is connected online, I would like to remind you that please address the question to the speaker that you want to address the question, okay? And then we will collect the questions and present to each speaker. Okay, so let's start. For me, it's a pleasure to introduce my colleague, Miquel Anglada. Miquel Anglada is a promoter of the Renewable Hydrogen Network of Catalunya. He is a physics engineer by Universitat Politècnica de Catalunya with a double master degree in sustainable energy systems. He has been involved in research on new technologies for hydrogen production, and more recently, he has been dedicating to the technology transfer support for new hydrogen technologies as the promoter of the hydrogen network, the ATOSCAT network. Okay, so he will talk about the role of innovation for the development of new hydrogen technologies in Catalonia. So please, Miquel.
Thank you. Can you hear me? Hello? Yes, okay. Hello, so yeah, my name is Miquel. It's a pleasure to be here. I'm the promoter of the Hydrogen Innovation Network of Catalonia. So I'll tell you about it and briefly, because I think we're a bit late. So this Hydrogen Innovation Network of Catalonia is an initiative funded by the Catalan government. It started in 2023. It was promoted by 5 entities: Eurecat, the technological center, which is now the coordinator of the network, together with Universitat Rovira i Virgili, Universitat Politècnica de Catalunya, so the Polytechnic University of Catalonia, the Energy Research Institute of Catalonia, IREC, and the Chemistry Research Institute of Catalonia, ICIQ. Okay. Now, after almost 2 years of operations, we have now 16 entities in the ecosystem, with more than 70 research groups and more than 350 researchers in the ecosystem. This is a public initiative. It's funded by the Catalan government, so we can only support new technologies developed in Catalonia, but not our collaborations can be also with entities outside Catalonia. As this map shows, especially in Europe, we have close relations with entities in Spain, but also in the north of Italy, for instance, Polito. We've talked a lot with Professor Massimo Santarelli, for instance. We have good relations with other ecosystems in Poland, in Sweden, in France, in Scotland, but also outside Europe, for instance, in Japan, Chile, or Brazil. Now, what do we do, particularly? Well, our goal is to support technology transfer, as Miriam was saying earlier, so it's helping research groups transfer their technologies to the market, identifying new transfer opportunities and helping them in the process. We do this by finding new synergies, alliances, and coordinated strategies among the members of the ecosystem, and also with external agents as well. We identify all the technologies in our portfolio of technologies. We have more than 100 technologies identified already. I'll show you later. We help valorize these technologies and identify transfer opportunities, and we give them visibility and dissemination with different events that we organize. Now, this simply shows that the technologies we identify cover all the hydrogen value chain, from production, storage and distribution to hydrogen usage, both as raw material or as energy source. well, we have more than 100 technologies, as I was saying. This QR, if anyone is interested, leads you to the portfolio of our technologies, which is published in the webpage. Now, why is innovation important? I'm going to be quick on this because this is obvious, everybody knows it. We're in a situation of climate emergency. This means constant change. We're constantly hearing about this new technology that will change the world. Some of them don't change the world in the end, but we need constant new technologies to overcome barriers, right? We have a gap between R&D and the industry, which needs to be covered. And we have, specifically talking about hydrogen, we have many technological barriers yet that prevent us from having large-scale hydrogen systems massively implemented in the world. We're talking about 2050, we will have this many electrolyzers, but as of today, we don't have almost any large electrolyzers in place. That's because we have too many technological barriers. We do have technologies right now, right? We have hydrogen buses. All of you that live in Tarragona, I think you already have hydrogen buses in Tarragona. I am from Barcelona, we also have hydrogen buses there. There's hydrogen cars. If you have 70,000 euros, you can buy a hydrogen car. It's that one. There's also electrolyzers. We can have AEM, alkaline, PEM electrolyzers. They are expensive. They can produce hydrogen at a very low price of 14 euros per kilo, which is definitely not viable in the industry. We have hydrogen storage tanks. They exist already. We have, well, this is not a hydrogen refueling stations, but we have hydrogen refueling stations. We have the chemical industry that consumes hydrogen. Actually, I know the number for Spain. We consume 500,000 tons of hydrogen every year in Spain, but it's not green hydrogen, because green hydrogen costs around 14 euros per kilo. That's being optimistic. So we have barriers, right? I have here some articles that I saw showing these barriers. We know that hydrogen production at less than 2 euros per kilo by 2030 is not within reach. Well, I was saying it's now 14 euros per kilo, so 2 euros per kilo is far away. The industry considers 2 euros per kilo the number in which their operations could start being viable, right? Then water shortages as well. You need 10 kilos of water to produce 1 kilo of hydrogen. That's a lot of water. We're in a place, I don't know about Tarragona, but where I live, we're constantly having problems with water shortages, right? We don't have a lot of water. So how can we produce a lot of hydrogen without this much water? And then, well, the other one, it simply shows that we don't have demand because technology maybe is not ready. So without demand, we cannot supply a lot of hydrogen, right? So a lot of barriers. That's why we need innovation, and that's why we have the hydrogen ecosystem, right? I'm going to show you some examples of some technologies that we have in our portfolio that can be related to overcoming these challenges, these barriers that I was commenting on. For instance, this technology, it's actually 2 buildings away from here in a pilot in Universidad Rovira i Virgili. It comes from a project that joins together Universidad Rovira i Virgili and Eurecat and also other entities. And it allows for the production of hydrogen with wastewater. Actually, with the treatment of wastewater, actually they can tell you about it better than me, but with the treatment of wastewater, you can obtain hydrogen as a byproduct, I would say, right? So you are overcoming the challenge of using water. You are using your water, but you're using wastewater, right? Well, they are building a pilot right now. I don't know if the pilot is finished yet, but it's one example. We have another technology. This is from a project called eLeaf, involving Eurecat. It's a 3D printed membrane electrode assembly, which is lighter than conventional, cheaper to manufacture than conventional, still in a low TRL, but maybe in the future this will solve some of the problems, for instance, the cost that I was telling you about. We have other examples, similar examples. This is a 3D printed ceramic solid oxide fuel cell and solid oxide electrolyzer manufactured in the Energy Research Institute of Catalonia. More efficient, lighter. So lighter for several applications. This is a challenge as well, the weight of these systems. This one is lighter than conventional. So overcoming another challenge in the market. And then safety. Safety is important when we're talking about hydrogen. Well, in Universidad Rovira i Virgili, they have this spin-off that was created last year. It's about wireless, autonomous, robust, solid-state hydrogen sensors. They can actually also detect other gases like methane or ammonia. the spin-off was created last year. All these technologies are identified in our portfolio among the 100 technologies that we have, and we're providing them with support to reach the market and help overcome all these challenges and all these barriers that I was telling you about. So what do we do? Well, as I was saying, there's a gap between basic research and whatever reaches the market, and we try to cover this gap, right? Simply helping take technologies from the R&D centers to the market. That sounds easy. It's not, but what do we do specifically? Well, we help identify roadmaps to the market together in close contact with technology transfer offices from each entity. We design this roadmap to the market, and then we have several tools that we use to help them reach the market, right? Or be more ready for this process, right? For instance, we have what we call the H2CAT vouchers. These are simply consulting tools that we provide to the group so that they can have market studies, patentability studies, business plans, financial plans, etc. We use projects in two different ways. We can either use a project to scale up a technology, so we help groups find new projects, collaborations with companies, etc., to scale up a technology, or we also use projects to identify new opportunities. Recently, we promoted the project with a group in H2CAT, and through the project, they identified that their technology could be used in a certain market segment, and now they are tackling that segment. So they are working on it. We're doing market studies now and identifying if that is really an opportunity, and we're going to go that way. Okay, so we use them both ways, and then we have mentoring programs because our role is to take them, if they're going to spin off, our role is to take them to the first investment rounds, and then we disappear somehow. So these mentorings are to prepare for this investment round, so to prepare for the pitch, etc. Then we also have training sessions and technology meetings so that they can find internal synergies, and they can also learn valorization, transfer concepts. And then we also organize different events. Here I have some examples. We organize demo day sessions, so sessions where researchers can bring their demonstrators, their prototypes, and show them to the industry. We organize market pool sessions, so where we can discuss with the industry and learn from their needs, so that to see if we can overcome them or help them overcome them. We have training sessions, dissemination sessions, etc. And once a year, we also have a Congress, the central meeting of the H2CAT ecosystem, which is called H2CAT Innovation Summit. And I'm happy to invite you all to come if you want. It's next 14th of November in Barcelona, in Cosmocaixa. Okay. And that's all from my side. If you have any questions, we'll be happy to answer together with Dolores also in the team. Thank you.
Thank you, Miguel. Let's continue with question and answer session. Both speakers, if you can sit here. I have to sit. Yes. We have some questions. Bart from Avantium wants to.
Very nice talks. I have a question for both. One question for each speaker, actually. Is my mic on? So first, you talk a lot about boosting the acceptance of green technologies such as hydrogen. But I think there's a risk there too, because there's probably a large group of people that's very eager to accept new sustainable technologies because it allows them, or it's a motivation for them to keep doing business as usual. And every time there's a news article out on a new technology on sustainable hydrogen, there is a risk that it's already accepted, and it takes away the urgency from people to reduce their consumption. It's already accepted before the technology is reality.
Huh.
So I would even say it's not the task to boost acceptance of hydrogen, but to provide a nuanced view. As an example, for instance, leakage of hydrogen, it is actually a problem, because if hydrogen leaks into the atmosphere, it slows down the breakdown of methane, which is a very potent greenhouse gas.
So I understand. You always have to balance risks and benefits. So maybe this conception of people that agree with these new clean technologies because they are cutting edge technologies and the future and so on, they don't know in deep what these kind of technologies can do in general for the climate and in particular for the economy. For instance, it depends on the frame. If the frame is the economy, you have to point out of the benefits the local community will receive when this technology is implemented. Take a look at the electric car as an example. The electric car is invented a long years ago, but there's a reluctance of both car companies and drivers to adopt this technology because cultural factors, the price, and different situations. So I think that the most important is to start providing knowledge to the people, and then they can make its own decision. But when you provide this information, you have to know which public do you address and tailor the message and use the appropriate channels to achieve that this message will be integrated not only in the mind but also in the day, in the how people can use hydrogen for cooking or for heating or for transportation, etc. I don't know if...
Well, I think that's also, if I allowed another question,
Yeah, sure.
a bridge to my next question. Because Miguel, you showed examples of hydrogen buses and hydrogen fueling stations, so basically hydrogen cars. My question is, should we use hydrogen to fuel cars? Because battery cars, electric cars, are roughly 2 times more energy efficient. So if we would go into hydrogen cars, that means twice as many solar parks. And you also indicated yourself there is not a lot of green hydrogen yet. So should we not first use the green hydrogen that we have, for instance, to make fertilizer?
Well, it's a complicated question. I would say, no, I mean, yeah, in a sense, you're right. I understand your question.
It's related actually to communication because what is the proper use of hydrogen? And that's also something that can be communicated, I think.
I understand the question. I don't know about communication, so I'm not going to be on that side of the answer. But like everything else, I would say it depends. That's the best answer. But it depends in any case. For instance, I know I'm not an expert on industrial scale hydrogen deployment or anything, but I know the case of Barcelona city, for instance. Barcelona has a metropolitan area of around 5 million people. So they have a lot of buses. And they started implementing hydrogen buses because at some point they were calculating having to have all the buses with electric batteries. And that would mean, well, all the buses, they have to be charged they have 4 hours to charge at night because due to maintenance and everything, they have 4 hours. All the buses have to be charged during those 4 hours. So imagine having all the buses you need in a city of 5 million people charging at the same time the electric infrastructure that you need, right? That's probably why in that case it makes sense to have some hydrogen buses so that you diversify. In every case, I don't know. So that's why my answer is it depends. for any use case, I would say it will depend. It's the best answer I can give you is we should do whatever is best in any case, right? Whatever makes more sense.
Yeah, thanks.
Okay.
Other questions, Toby from Solaronics has a question also.
Yes, this is question for Miguel. In your H2CAT network, are you also, let's say, interfacing with venture capital and the family office kind of for the financing, or are these people kind of involved, or have they kind of a scouting way of looking for the new startups that may pop out of this thing, or how is the ecosystem, let's say, equipped for financing the new things that may come out?
Yeah, we do not directly finance, but we make use of the financing tools that exist, both public and private. So, so our role is like some sort of low TRL incubator, let's say, but we help them take their technologies to the first investment rounds. So we have relation with VCs, with BAs. So we provide them with the contact. We actually organize investment days for the spin-offs that we help create with the investors that we know, that we have relation with. So we both use public financing that's available for these types of projects, both in the Catalan level, Spanish level, even European level. And then we use the private funding opportunities as well, both the direct relation we have with investors, also in the particular case of Catalonia, there's a governmental tool which is called Investment Fund for Advanced Technology, FITA. It's partially funded by the government, and it's an investment fund to fund spin-off startups. So we also make use of that part of private funding. Yeah.
Awesome.
Okay, thanks.
I think that we don't have more time. Thank you both for your contribution, and thanks for coming.
Thank you.
Okay, let's just start with the last part of the event, the roundtable discussions about new technologies and solutions for decarbonizing the industry. For me, it's a pleasure to moderate this roundtable as part of this SunCoChem Final event. Okay, bye, Toby. Thank you. Okay, Miriam, I start. Okay. Okay, so you are putting your phones. Okay. So why we choose this important topic? Okay, you know that the challenge that we are facing today of decarbonizing the industry has become more important than ever. Actually, a lot of industries around the world are working to decrease their environmental impact and shift towards a more sustainable practices. And in this context, the development and also, more importantly, the integration of green technology is not just something to meet these climate goals. It's also a key driver, for innovation, which I think is the key to build this new industry and help the industry and build an industry that is resilient and more ready for the future. So to discuss about this topic, we have a very distinguished panel of experts that will share their perspective on this important topic. I will start introducing them. I think I see one that has a phone already. So, okay, I think we have Carlos. We have Enrique Pascual. Please join us here in the table. He's a solar researcher engineer in the R&D unit of Acciona Industrial. He will give us insights into how large companies like Acciona perceive the integration of renewable energy technologies and the challenge they encounter when scaling those solutions. So please welcome and take a seat. We have Julio Lloret Fillol from ICIQ. He's the group leader at ETHIC and a career researcher. Julio will share his views on the most promising emerging technologies in decarbonization with a focus on their potential short-term industrial impact. Welcome, Julio. We have Nuria Lopez here in the audience. Nuria is a group leader at ICIQ, who will discuss how the development of advanced catalysts can transform industrial sustainability and emission reduction strategies. And Carlos Simelis, you are ready? Simelis Hernandez, he is co-leading the technical coordination of SunCoChem project, an associate professor at Politecnico di Torino. Simelis will reflect on the technical and collaborative challenge faced in implementing the innovation that we propose in SunCoChem, particularly through this project. Okay, and finally we have Carlos. No, where is Carlos? Sorry. I saw you were there. Come. I don't see your shirt. Carlos Molina. Carlos Molina, coordinator of economy, international trade and innovation at FEICE, who will provide his perspective on the economic and regulatory measures that can encourage industry to adopt green technology. Okay, so thank you all for joining us, and let's begin with the discussion. Okay, so the first question is from Julio. I stay here. Okay. The first question is from Julio. What emerging technologies relate to decarbonization do you consider the most promising in terms of short-term industrial impact? And please, the rest, feel free to jump into each other's response, of course.
So, thank you very much for the invitation. That's a very difficult question. Okay, so there are organizations that has been directly devoted in order to try to tackle this problem. So I'm going to say is my opinions, but they are influenced on one of the projects that we are involved in ICIQ. That is SunEnergy. Well, actually SunEnergy is an initiative, and SunEnergy is the project that has this initiative. In principle, this is a association initiative that try to bring together different shareholders in order to push decarbonization to the synthesis of solar fuels using renewables. So there is basically 50% academics, 40% industry, and 10% of government in this initiative. That's how it's more or less distributed. So 300 organizations, so it's relatively large and has some impact. So one of the roles is to try to make a roadmap and to see which kind of technologies can, where they are, what kind of material they have right now, and how they're going to be in 2030, 2040, and 2050. And there has been many discussions, and it's still, so I mean, it's a living document, let's say. So you need to analyze and to see, because the things are evolving. So what we can maybe say, or how I'm influenced by this initiative, is like you have two types. So you have direct conversion and indirect conversion. The direct conversion are those that, like photoelectrochemical devices, that they capture sunlight and then it's transformed using a semiconductor and a catalyst on the top and things like that, or nanoparticles in solution, which are still a low TRL. And then you have the ones that they are indirect. And then the indirect is like you have steps. So you have the best of each technology, like photovoltaics. Photovoltaics is mature and we know that it works. Then hydrogen, green hydrogen using electrolyzers is already in the market. It's expensive, but it's already in the market, and actually can be reduce the price a lot. So maybe this combination of technologies probably the ones that they are going to get closer in the market. Then once you have the green hydrogen, then you can use thermal transformation to do hydrogenation of CO2 to methanol. So I mean, that I think to me these are the best ones that now they are the best positioned in order to access to the market. What I would like to see, I would like to see more developments in catalysts, more development in membranes, and try to see how we can advance also in other routes that could be possible, that at some point they are more efficient in terms of materials or in terms of price and so on. But this is it's an open question still.
Okay, thank you. So you are saying that those that are using the renewable energy through an indirect process, no, are the ones that are more close to be implemented in the market. For instance, the ones that you are using directly green hydrogen to reduce CO2, for instance, which the thermochemical conversion is a process that is much more mature in terms of technology level than electrochemical CO2 reduction. No? But in your field and the technology that we propose here in SunCoChem, what is your opinion about electrochemical devices to reduce CO2? Maybe more electrochemical ones, that not photoelectrochemicals, that are even more late. No? Do you think that they have they can be implemented in the future industry?
I hope so. I hope so, because it gives us access also to other type of alternatives to synthesized chemicals. No?
Yeah, more direct. No.
Formic acid, for instance, it could be a good route to synthesize formic acid. Maybe CO2 electrocatalytic reduction of CO2 to methanol. It could be interesting, although there is a fair competition with the thermical one. Maybe C2 products, maybe can work also by electrochemical means, but still in large initiatives, large infrastructure to transformation of chemicals probably is going to be thermal in many cases.
Okay. Simelis wants to
like to
say something.
That, based on a study that we recently performed, that was based on primary data of our experiments on thermocatalytic conversion of CO2 to methanol and electrocatalytic conversion of CO2 to ethanol with the same kind of catalyst. We observed that if the electrochemical process is able to achieve the target, the KPIs that are needed for commercial implementation of this technology, like very high current densities that are achieved, more than 100 milliamp per square centimeter, or very high selectivity towards the final products that we like to produce, more 90% of methanol, for example, then the direct comparison of scaled out processes for producing methanol, for example, from electrochemical and thermochemical technologies, are both of them competitive, either from an economic point of view or from the environmental point of view. And the interesting result that we also obtained from this analysis was that actually electrochemical processes are even more competitive than thermocatalytic ones if you speak about lower production scales, and also applications related, for example, of production of methanol as a solvent or a chemical for laboratories application, for certain applications. Also, it is a process that can be perhaps be more decentralized than big plants of thermocatalytic reactors. And so I think that the best in the future regarding the carbon capture and utilization will be to diversify the application and the application of the different technologies that will be developed. And I think that every technology will find the best place where the techno-economical and sustainability and also the size, the volumes of production will fit the best.
Okay, so we continue with you, Simelis. I'm sorry, but I have to be behind you. But Simelis, in your work with SunCoChem, what have been the biggest technical challenge that you face in implementing our technology?
Yeah, I could say that this is a topic that we have discussed several times today. But I like to start from the beginning. In the SunCoChem approach, we like to propose an integrated process, right? And process intensification combining CO2 capture, electrochemical, photoelectrochemical CO2 conversion, and hydroformylation. So a further process of converting this intermediate that was the syngas. And this, I think, was a very, very huge challenge that we we envision in our ideal proposal. And we face a lot of challenges to make possible these three processes in the same place. we were able to select the best ionic liquids that work in hydroformylation and work in the electrochemical conversion. We were able to develop catalysts that work very well in both cases, and that we were able to immobilize also in electrodes, but we were not able, for example, to actually couple the process conditions that are very different for doing hydroformylation that is performed at relatively high pressure and temperatures respect to the ambient condition of the electrocatalytic process. But I think that this, for example, is a challenge that perhaps in the future we can, by continue the research and development, can be tackled. Another huge challenge that we face, but also I think any project trying to do this kind of technology is facing, is the scaling up of the catalysts and the electrodes, because usually very small electrode size are exploited and developed in the lab, 1 square centimeter electrode size, but when you like to scale up that to 10 or 100 square centimeter, then you find that exactly the same electrode with the same catalyst load in the same technique, etc., in the big scale is not working in the same way. So you need to re-engineer and rethink, re-optimize, and this was a huge challenge that fortunately we were able to tackle in the project. And the last but not least is also the engineering of the big scale reactors. This is something that has very few times has been attempted in all projects, even European projects that I have seen. And it's something that is needed, in my opinion, because there are a lot of engineering challenges that also we were discussing today, with money they can be solved, probably fast, but need to be solved, by the way. So I think the first this will be done, the faster then the new catalyst will be implemented in those reactors, and we can go ahead with this development.
Okay, estimates, thank you. But you know that when you have a lot of experience working in European calls, and you know if you want to obtain some financial support, you have to be very ambitious and to propose a lot of challenge. For instance, in that project, we propose innovation in all the components, the membranes, both membranes, the capture, the ionic exchange membranes, the catalyst, the scale-up, the integration, the device. I think, and was for a 4-year project. And in the end, at some time, you can be innovation forever. At some point, you have to stop and start building something and start talking with Freddy. So please start with developing the device. But it's true that in the end, you have the materials that you arrive to obtain. And do you think that there is something that may change from Europe to try to, I don't know, it's an open question, you can, not just for US, Imelis.
I think that this is a huge problem. So equivalent initiatives in the States, they have 60 million euro. Okay, I'm advisor to LISA, to the Liquid Alliance in the States, and they have 60 million. And we are getting 4 each for 4 years. This means that our ecosystem is extremely fragmented. Even if we try to do our best, and it's very nice that you are inviting us here. So I'm coming from the competence, one of the competence.
No, we are
projects.
not the competence.
No,
don't say that.
But you understand what I mean. Basically, I mean we have reached a level where the European funding scheme is not supportive enough. And it's not supportive enough because we are getting all these problems related to engineering, how to upgrade some of the technologies, the small technologies that we are having, and some of the developments that have been collected for the last 10 years in different European projects. In SunCoChem, in Flow Photochem, also in ELIF, and in many others that we have been involved. So this is a very big limitation that it's preventing us from going into something much more interesting. And to me, I mean, we need to lobby in a way, and I think SunCoChem might be a good way, but we need other ways in order to make this transition into something that can be useful for all of us, and actually for the society, and for creating all these jobs that we will need in the future. And this also goes because in Europe, it's not the only problem to funding, it's also a big problem of how the regulations apply in different places. And this is, again, a big hurdle that we cannot jump. So things that would be likely to be approved here will not be likely to be approved somewhere else. We have another problem related to the over-regulation. And this goes for materials that are considered critical. And I guess that you were fighting not to use cobalt and not to use nickel today, but tomorrow you can use nickel but not cobalt, and all these kind of things. We need a regulatory framework that is stable and clever and help us. Okay, us as a community, because now it's just preventing us from going further. And I'll stop here because I could be talking on this.
Okay, let's continue with you, Nuria, with your question. How do you think that the development of those catalysts can transform the way the industry approaches sustainability?
I mean, catalyst development, it's a long path. I mean, we have had catalysts that were better than the ones that were implemented in industry, and it took 10 years. So basically, it took making a new plant. And in the new plant, there was this new catalyst, okay? They will not change the old plant. What we are talking is an extremely mature set of technologies that are based on fuel cells, that are based on fossil fuels. And we are trying to transform this 100-year-old huge industry in a very short time without having much input of how to do the new things, or how to replace them, or having only partial support on things. So even if we, let's say, tomorrow, Simelis and Julio find a new catalyst, we will have problems to implement them, let's say, in next year. But we will have problems to implement them in 5 years' time. Okay, so to me, we need to develop. Our industry has a lot of capex, so this means there is lots and lots of investment that is needed, and this makes it very slow in answering the pushing questions that we are having. Okay, and this is threatening our industry in Europe because we are not competitive anymore, and we should stop lying. We are not competitive anymore. Most of the chemicals have been moved into Saudi Arabia, where you can generate all the energy that you want very cheap, or you can just get the fuel out. So either we do it right and fast, or we are out of the picture. And I'm sorry to be so pushing, but saying that our cars will go with hydrogen, for instance, or I can say many other things about how we should do things. And we shouldn't lie to ourselves, because we are in the wrong place in history now. So, sorry.
Okay, let's continue with Enrique. From Acciona perspective, now from the industrial point of view, how do big companies like Acciona see the integration of renewable energy technologies in industrial decarbonization? And what are the main challenges you face when scaling these solutions?
First of all, thank you very much for inviting me and having me here. It's a pleasure to come back to Eurecat after 4 years, doing my PhD also in Eurecat Mataró, so it's my pleasure. So from the perspective of Acciona, you have to take into account that Acciona is a very diversified company. But well, in one of the lines I'm working in is Acciona Industrial, which belongs to the infrastructure. So basically, we are EPC, so engineering, procurement, and construction company. So in few words, we focus on design and build power plants. So in this scenario, we are very committed to reach neutral carbon emission. And to tackle this, we are in different sectors. Of course, we are in the solar sector. We have solar technology, both concentrated solar technology. So, as an example, we have Cerro Dominador, 110 megawatt solar tower plant in Chile desert. And one of the nice feature of this plant is the idea to storage energy in molten salt. And this is very relevant for the future, especially we'll talk later. But it's because of the dispatchability. It means like to match the supply and the demand of energy. Also, we have built photovoltaic plants, waste to energy. So basically, is to convert waste into electricity by burning. And in this regard, I think that match very nicely the CO2 capture. We are also investigating some research lines in this regard, and also wind power. So basically, some of the main challenges in this perspective is to shift the paradigm from going from the carb or fossil fuels based technology towards renewable. Few years ago, it was so easy to match the demand because there was a limited number of power plants, so their production could be very nice adopted to the demand. But however, over the increase over the recent years of renewable energies, there is not so easy to match this supply with the demand. Because as you can see, the more power generated by solar and wind is highly affected by the weather. So the current situation is that in some times of the year, especially during noon, there are some renewable power plants that they cannot inject electricity into grid. And this is because, as I said before, the demand is not balanced. So I think from the main challenge will be like the storage of this energy, because if the ever-growing of this electricity will keep going of this trend as we see, because of the really low price of photovoltaics or also other technologies, I think how we handle these electric grids, and also if we develop new strategies to storage energy, I think will be like the most critical point towards the of this next scenario.
Okay. So I think that what's your opinion about to bring the electrifications into industry that it strongly depends on the carbon, on carbon use, like the industry of petrochemical industry, you know, like the concept that we have here in SunCoChem, where this renewable electricity is stored in the form of chemical bonds, no? From Acciona perspective, which are the best technologies that you think that are going to overcome those barriers, no? To be close to those industries that strongly depends on the use of carbon?
Yeah, I mean, from Acciona perspective, obviously those industries that are not strongly related or highly affected by or need this combustion during their processes, of course they will face more challenging to implement. But perhaps there are some very nice examples. Recently in Sevilla, there is one company, Heineken, which they developed their own concentrated solar plant in order to produce their own heat for the process. So thanks to this, they can reduce their carbon footprint for around 50%. So if we have in mind, like for instance, like photovoltaics or even thermal solar, they were focused on even the small scale, let's say in the household for the house self-consumption, or very big commercial plants. But nowadays, I think there is a very nice market niche in between this small and large scale in order to reduce the carbonization of certain industries. So, for instance, like there are many, like for instance, logistics. In the case of photovoltaics, they simply implement those photovoltaic panels on the rooftop, and they can extract green electricity. So, I mean, of course, we don't have a general solution for all industries, but of course, there are some industries will have easier to pave the contribution to reduce the carbon emission thanks to this electricity or even heat.
Okay, thank you. And Carlos from Feike, also an industrial point of view, from economic and regulatory perspective, what measures do you think are most effective in encouraging industry to adopt those green technologies?
Okay, first of all, thank you for the question, and thank you for having me here.
Me siento.
Don't worry. Well, the first thing, the first measure that comes into mind are the market pool measures. Well, first of all, I want to say that the chemical industry is fully committed with the double, not with the double, but with the quadruple transition. The double transition is horizontal for many other sectors. They include goals like digitalization and neutrality, climate neutral. But we also want to achieve two more goals like circularity and safe and safety by design. However, manufacturing circular and low carbon products has a high cost that we cannot translate to the final customer. These clients or consumers, since our products are sometimes within the products, they are not willing to pay any more costs for these products. So we have to try to implement measures, well, not measures, but we have to implement measures to help these products to get into the market. Same thing happens with technologies. These extra costs come from different other places, like raw materials, new alternative raw materials like bio or CO2 free or recycled raw materials. They confront with fossil raw materials, and the costs are much higher. And the cost of changing the system of energy for others, like electrification, it's costful. However, going back to the measures, I started talking about the market pool measures. We are still working on this point. Yeah, so I will be very slight in the question. First is the green public procurement. We're not too comfortable with this concept since our products, you can find them, they don't get to the customers. You find them within other products. So this could be a message, but this is not the best one for us. Another measure could be to reduce the VAT tax. Another measure could be to create a new label where it states that this product has been made with green technologies. And another measure could be the modification of the fee for the how to say in English, amplified responsibility of the producer for circular products.
Okay. Do you think that the administration should be involved as a partner in the consortiums of projects like this? I think maybe
they are at some part. Well, not enough, of course. No. As Monica was saying, there's a big problem of funding, but we have a small one. They should be more involved. That's for sure. I mean,
yeah.
That's always our petition to when we meet administration. but that's something.
Yeah, because we never advance, no, at the same rate. I mean, it's a mismatch there. So.
Yeah.
Okay, so I don't know. Now I will open the floor for you to comment on each other's response, or we can go to a broader discussion. I don't know if someone wants to comment something about your. Okay, so another open questions. Which industrial, it's an open one, no? Which industrial sectors are best prepared to adopt decarbonization solutions, and which face the greatest challenge? I don't know who wants to jump on that question.
No. I'll be the first one. For us, the chemical sector, we are a sector hard to abate, as other sectors like cement or iron. Well, we provide solutions for over 98% of economical activities like consume, energy, transport, construction, food. So we provide solutions that depends on innovation. But on the other hand, we suffer, like Monica was saying, we're overruled sector. We have more than 113 pieces of legislation in Europe, only for the chemical sector. That means 14,000 pages of legislation. That it's something we cannot deal with it. I mean, in other countries like China or the States, they have more. They are more open to create investment in the chemical sector. That makes it very more attractive and more pragmatic for everything.
Okay, thank you.
I would like to comment. For instance, we have to consider that transportation, like road transportation, for instance, they can go electrified like very easily, as we can see electric cars going around in roads or even in cities. So it's like a mature technology. But of course, we have to consider if we all of us go into electric cars, if we have enough electricity in our grid, or even our power plants are ready right now to shift towards, like the current scenario, towards an electric one. So for me, of course, we have to be very aligned, all the stakeholders, as if imagine the battery industry does not provide enough batteries for those cars. This would be like very challenging situation in order to address this new challenge. So of course, this is not only a matter of industry. I think it's simply to make sure that all stakeholders push in the same direction. So and make sure of the feasibility. So perhaps in some industries it's so difficult to shift, like in a short term. Perhaps it would be easier to think towards long term and not to stick with only one technology. Perhaps the more technologies that we have, the more likely that those come true.
Okay. Something want to point? Something?
If I may add something, yep. I think that in general there are many companies that are willing also to implement new technologies. For example, we have, I also coordinated technically another European project that finished 1.5 years ago, was the Recode project. It was mentioned today by Iolitech, by Boyan. And in that project we have an end user that was a cement company, Titan, and they were very engaged in the project and very willing to implement our capture and conversion technologies. And was also impressive that they liked to maintain in operation even the CO2 capture unit even after the end of the project for months. They were trying to take again data from the demonstrator. And I think that this is a very key message, right? That the hard-to-abate companies and these different big companies are just willing to have the technologies that are ready to be used. I mean, they are interested in this. So obviously, as Nuria was also saying, we need to have the right investments for the research and development to be able to bring the technologies to the level, to the tier 5 level at least, that then can become tier 6 by putting in a plant, and a real plant. And if then it works, I think the same companies will be willing to go ahead with the development and right to tier 9. But I mean, this is a game that we need to...
To me, it's a little bit like we are forgetting the scale of the problem every now and then. And this is a matter of scale. I agree with you that most of the companies will be happy to have a solution for the CO2 because they will place them at the very top of the segment and they will make double the money next year. But it's true that we are working at TRLs that are very small, and we need support because there are things that we don't know how to do them. So I think that any kind of public-private partnerships that we can reinforce in order to translate the technologies are actually extremely powerful. Yeah. And that we are missing, in a way, a lot of strength there. And part of the problem is because the CapEx and the construction of all these things, it's expensive compared to other technologies. I mean, I'm also in the digital, and in the digital you can make money very cheap, very early, very soon. Okay, so it's not comparable.
But for instance, the chemical sector, there are some technologies that are more mature in TRL. For instance, the Fischer-Tropsch technology that works since the second war, and they are not trying to integrate and transform the model, the business, towards those technologies that can come from CO2 and also from hydrogen. I mean, what do you think? Maybe you, Carlos, from the industrial company.
I'm not sure what you're asking.
I mean, the chemical companies. There are technologies that are more mature in technological level. No, for instance, the Fischer-Tropsch synthesis to produce naphtha or synthetic petrol, or synthetic fuel. And there is something that is mature as level of technology. For sure, there is always innovation for catalysts and so on, But they are not talking about that. They are always just talking about hydrogen, implementing hydrogen. There are a lot of petrochemical companies that actually adopting electrolyzer in their productive model. Do you think that that makes sense? For instance, for you that comes from that sector.
Well, I'm sure. I've been in this innovation sector
for another
too short time to know this. I'm not sure about this.
Okay, so I think we can continue with the next question. How can we foster greater collaboration between the private sector, public entities, and academia to accelerate the adoption of green technologies?
What you were just saying.
Yeah, I mean, reducing the barriers for the interactions. So this means providing money at the scales that we haven't seen. That's a problem. I mean, it's a scale.
Okay, I think that we can open now the discussions from the audience. I don't know where it's Miriam. Okay. I don't know how to check on that. If you can help me. I don't know if there are some questions from the audience. Angelica, please.
Yeah, just a comment on this last point. Yes, you're right. So thank you. First is okay. Now it is working. Thank you for the discussion. Very interesting, and also having different point of view. We say and we know that the limitation of the research is that we reach a small scale, as Nuria said, and even it is very hard. There are, for example, some European project initiatives that are the innovation actions that require to reach TRL 8, for example, that are supporting the industries with a partial financement. It's not 100% financement. And just to give an impression, I was trying 4 years ago to to write a proposal in an innovation action perspective. 4 years ago, it was too early for the industry to be interested in putting some TRL-8 plants in their own premises and also to spend money for this, because at the end it's an investment. Maybe this could be, maybe we should, when we reach a certain level of awareness on the technology, maybe we should make the step further, involving, in this case, more the industrial players, to say, okay, we now know after 4 or 5 years that the technology can be a solution. And also we said that depending on the needs, one technology will be more successful rather than others. But if we can have the single company with a specific, single means sector, a single sector with specific needs can be maybe the occasion to play together with the researcher to make this technological improvement going towards something that can be at the end the TRL-9. So this is just a comment.
Well, this is our reason to be. For SunCoChem Spain, we connect ideas with companies and universities and technological parks where we put together, we meet all these companies or ideas to work together to create synergies.
Yeah, but my perception is that maybe now the companies and also the research part are ready to join together to have this focus more effective rather than 5 or 4 years ago, in which there was this ideal goal to face the climate change in some way, but the cost for the industry was so high that it was not appealing, and also the scientific return was not so consolidated. Now several projects have shown several interesting results on the CO2 capture, on the CO2 transformation in whatever technology. So yes, we need some intermediate part, but I think that now the point is that maybe it is a good time to start to move on, because the companies are more interested in joining and to invest money to this new technology.
Well, we're the first sector in innovation. So I think the companies are willing to spend money on innovation, but sometimes, as you said, this is not the time. As much as you can spend, there will not be enough because we are not in that moment. But we always receive creative new ideas that work towards that goal to make it possible.
That's nice.
I would like to comment also on your comment. In the case of Acciona, for instance, Acciona Industrial, in our research and development unit, we are also validating and testing some CO2 capture technologies, for instance, and exploring, and validation this idea as a prior step towards this industrialization. Of course, before going to the market or to your customer, you have to make sure that this technology, of course, is reliable, is cost effective, and you have clear like the limitations and so on. So at least from Acciona, we are collaborating with some industry, and of course from the industry perspective, it's very nice to have at least like a pilot system in which you can really prove that it's not simply simulations, that the whatever solution works as expected, or at least to have like a validation platform in which you can operate. For instance, we are involved in one of the European projects as well in CO2 capture, the CalBi, which is also looking at the calcium looping system. So yeah, of course, this is like the pre-stage prior, like going one step further.
Some more questions from the audience? Okay, so we have some questions from the online attendants. Antonio Martins to all panel. Is it possible to fully decarbonize industry without green hydrogen?
That's easy, no.
Not possible.
You need hydrogen. You need hydrogen for everything. You will need hydrogen to make methanol. You will need hydrogen to make ammonia. So, no.
Yeah.
I mean, another way to answer is that we need to diversify the different technologies, and among them there is also hydrogen production, surely. I mean, to exploit the thermocatalytic processes that are already well developed. So,
But
I mean,
you will
we
need
need
the hydrogen.
But
you will need hydrogen for those.
Yeah.
But
I mean,
it's
the
so
molecules at the end, they contain hydrogen, so you need to put them somewhere.
But it's true that sometimes when you are developing those technologies that you mentioned, Nuria, about producing ammonia from hydrogen or hydrogen from ammonia or producing methanol from hydrogen, in the call they specify so much that should become from green hydrogen. Do you think that it's necessary that maybe we can go in parallel, no, to developing both technologies? But sometimes I think that it's not necessary, no, to integrate directly the use of hydrogen. What do you think?
I think it's important to integrate the use of green
Since the
hydrogen, because
beginning.
otherwise we do nothing. I mean, if, for instance, ammonia, the penalty that we are paying is the formation of hydrogen. It's not the formation of the ammonia itself. So if we don't use green hydrogen, we do nothing. So we need to use green hydrogen. For the methanol, the idea is to use methanol is to transport hydrogen, a sort of hydrogen, from places that energy is very cheap. Otherwise, you don't produce methanol in that way. So take CO2 plus hydrogen, hydrogenation, make a ship full of methanol that you ship it from Chile to Europe, and then you use it here. Okay, and the ship use methanol, like fuel.
Mars.
That's it. That's it. And that's so you need huge amounts of green hydrogen in order to to do something. Even when you use CO2 for main methanol, you still are neutral in CO2 in the best case, because if we account for all the technology that you need to develop in order to be able to do so, you are producing CO2 as well. So we are decarbonizing a part, but not to zero. And if we don't use green hydrogen, then we do nothing then.
But for instance, a company that wants to produce synthetic methane, no, and wants to adopt capture and production of methane from CO2, do you think that they have to implement an electrolyzers that fit into their process, or they just buy this green hydrogen to another company?
I don't think this is a problem as far as it comes from a source of hydrogen that is green or relatively green, because you want to be sure that, in the end, hydrogen is hydrogen. Hydrogen is a molecule. It doesn't matter that you produce in one way or another. In the end, if it's pure enough, you can use it for every process that you want. Hydrogen is a molecule. So then you can implement in-house your electrolyzer, or you can buy green hydrogen via somehow. But at least you force that the technology use green hydrogen, and this force the technology to advance. Also to all the shareholders to push further to reduce the price. It needs to be done in a scale. If we don't do it in a scale, we don't know how much we can reduce the price.
I think again, we are forgetting the wonderful example of solar. Solar was nice. Solar, I remember when I started going to conferences, and that was a few years back, it was so expensive. And now solar is nothing. It's really nothing. Everybody has solar at home. And it comes from a very fast deployment in China, and very fast production in China with the methods that we know that will not be fulfilling of the European regulations. And we know that, all of us. But that's the thing. But now it's so cheap that everybody has it installed, and you can, if you install it at home, in a couple of years, you don't need to do anything. So basically, your numbers are back to black in a couple of years. Trying to do the same kind of thing into a huge problem like industry. This means that you need to segment all the different needs to adapt them. For a system like the refinery and the chemical pole, that's an enormous amount of money, whatever we do. And I think that that's one of the major bottlenecks, that it's really It's a huge problem. It's not a small problem. Small problems, we can deal with them. We can produce molecules. I mean, they can produce everything. I'm only doing simulations, so I can produce everything too. But you know, it's of a different kind. But I think it's important to notice that the scale of the problem needs to be adapted, and we need to adapt our tools. But that there is a potential to be. There shall be solutions. We will find the solutions. It's just how much we need to invest in order to get these solutions right on time. And someone was saying, yeah, but you can try to negotiate with your community. Yeah, because cement, you produce it everywhere in the world. But if there are some things that are cheaper to produce somewhere and then you ship them, that's a different type of game. And I think that we need to define very well which are the games, the different games that we are playing, to identify which are the niches where we can make benefits, being Europeans and being with our constraints, okay? We know here, Catalonia, Spain, Italy, we will not have problems. I mean, we can just dry our clothes outside. That's not a problem. We will have cheap energy. But are we willing? I mean, this is not the standard European case, okay? They will have more problems than us, but then when we try to put our energy in the grid, then it has to cross France, and then we know it doesn't, okay, for instance? So I think that there are lots of things that we can do. I mean, from the practical aspect to the more applied ones. And some of the regulations need to be lifted so that we can all benefit from this energy, from the conversion into things that we can use. Now, I think that there is a very nice example. There is this small company in the States that they were using SAFs, that they were generating SAFs. And they have gathered lots and lots of money, and they had the plant, and actually they have a small plant in New York, which is something that I found amazing for fuels. And that would be very difficult to have in Europe. And I'm jealous because I think that they have done the right movement. They knew that there would be some support for fuel industry, I mean for the planes, which are hard to abate sector, like the chemical sector, and they knew that there was a niche there, so they basically built a demonstration plant. They gathered enough money to make it a little bit bigger, and now they are supplying, and they have this wonderful marketing around this. So you can even get a bottle of, I don't know what, I mean, it was something nice that I got once. And you know, I mean, if they can do it, why we cannot do it?
And why do you think that we cannot do it?
Have you tried to make a plant close to Tarragona? I don't know. I mean, I'm in the last 50 years. I don't know.
Okay, we have a last question from the online audience. Is chemical industry reluctant to develop and put into market chemicals from converted CO2?
No, I don't think so.
No, they would be happy to do that.
Yeah, I don't think so. I mean, we have discussed
Yeah.
today about the perception of the industry stakeholders about exploiting these sustainable technologies. There are other barriers other than just be able to say we are doing sustainable products or green chemistry in our. We have green chemistry in our products. There are the challenges are others, no? The cost, the efficiency of the processes, the quality of the final target products. So there are other barriers, not the perception of stakeholders about this.
Okay, if there are no more questions, I think that we have reached the end of this interesting roundtable discussion. I just would like to thank all of you, your panelists, to be here as a speaker and joining us in this final event. Okay, so I think we have reached the end of the event. Also, I will give the floor to our beloved coordinator Maria to give the final closing remarks.
Not? Ah, yes, now it's working. Yeah, bueno, let me thank again our presenters who have come here today and have been generous enough to put together slides and or to come here to share their knowledge, their experience, and their opinions. Has been priceless. For us, I consider that with the agenda we had today has been really intensive because there are many things to show. Thank you for being willing to learning about our project, our SunCoChem. We have really productive. We have learned some of the technologies that are more mature and more ready to reach the market, like the bipolar membranes or the polysulfone membranes or ionic liquids. We have also learned that as in this roundtable, we're also pointing out we need more time and more research and more investment and more work and maybe a change of legislations and minds of politicians in order to get the best materials in terms of catalysts and so on. But, bueno, give us time. And I also, the main goal of the project, that was the development of the reactor, thanks to EasyTech. Bueno, I think it's the biggest of these characteristics, as far as we know. And bueno, I like to think that in SunCoChem, these are our 2 pennies to make or to try to make the chemical industry more sustainable. I hope we have done something about this. Bueno, we have also had, of course, the presentations on the green technologies, especially the initiatives that are being moved around Catalonia, because Miriam is working very closely with them. And we have also had this very interesting roundtable, because sometimes, as Nuria was saying, we need to hear the truth in order to be realistic and really know which paths to follow. No, at the end is also knowing what has more demand, what's the acceptance and the willingness to be by the industry to be adopting the solutions, and if it's going to be accepted by the consumers. We had the Hellenic University here explaining us how the industry and consumers point of view are. We had also Enrique, the ones of the communications. I was really interested also by his way of explaining us how to better communicate, but we have to be careful to communicate it in the right way. So there are many things to take into account. There are many things that we have to advance, and there are many things to change before making reality. Many things. I'm sure I'm forgetting something now. I'm looking at Enrique with the environmental impact, but of course we need these studies and the operando techniques developed by IIT, which I think that will be very useful for to study many reactions and being included also in other projects, not necessarily European, but also private, etc. So it has been also a push even in analytical methods. As I said, I'm sure I forgotten somewhere something, but last, I would like to thank all partners and all people who have been involved in SunCoChem. You have made my role as coordinator so easy with your hard work and your big commitment. It has been really great. Yeah? Our time is going to be up soon, but we still have some months months to go for the final reporting, etc. But bueno, again, thank you. Have a nice evening. Have a safe trip home, and see you soon. Okay.